In this video, we're going to go through the data section of the Crystal Violet lab. We're going to do all of the data analysis required for this section. So we're going to start with the calibration curve. So the lab requires a table that should include all of the solutions, including the stock solution all the way through solution E, and it should have all the concentrations and absorbances. So on Google Classroom in the pre-lab, the easiest way to accomplish this would be to take your data table from the pre-lab, and I'm going to copy this into my lab document. So under the data section, this is going to be my data table for the calibration curve. So I'm going to call this part 1. And I'm going to paste in my table here. Now remember, tables need to have a title, and the title should be reflective of what's in the excuse me, what's in the table. So you can create a title yourself, or you could use ChatGPT to generate a title. But again, it should be reflective of what's in here. So I'm going to use a terrible title. You should come up with a better title that is reflective of what's here. So what I'm going to do is I'm going to change this. Instead of calling it predicted absorbance, I'm going to just call it absorbance. All right, and then you could fill in these from your pre-lab because you know what the concentrations are. I'm going to drop out the highlighting here. So I would fill in all of the absorbance values here that you collected during the lab. Okay, so that would be the first part. So let's go back and let's look at the requirements. So now it wants a graph of your absorbance values versus concentration. So I have my data file for the calibration curve open in spectral analysis. Okay, now this is a sample calibration curve, so yours probably looks different. And I'm going to just go from the beginning. So I have all my data points here. Now this is a very clean calibration curve. You may have some outliers on your data. So if you have any outliers on your data, so when I say outliers, I'm talking about points that don't make sense. So for example, if I had a point down here, that doesn't make any sense because as I increase the concentration, as I move from left to right on the concentration, my absorbance should increase. So if my concentration increases, but my absorbance doesn't increase, that would be incorrect. So if I have a point way over here that doesn't make sense, I can delete that point. Likewise, if I had a point maybe in this area up here, that doesn't make sense either. So when I have a very low concentration, I shouldn't have a very high absorbance. So if you have any outliers, you can delete those. So if I want to delete this data point, for example, I would click on it and then go over to my table. So you can toggle the table on by clicking on this icon. And all you needed to delete is the concentration. So I'm just going to click on it and press the delete button. And that data point disappears. Okay. So if you have great data where everything is kind of lines up or it's close to being lined up, that's fine. Next, I'm going to insert a trend line because our calibration curve is used to kind of find concentration. So I'm going to go down to the lower left-hand corner and I'm going to click on Graph Options. And I want to apply a curve fit. This is going to generate a line here. I want to do a linear curve fit and I'm going to click Apply. Okay, so it finds a line of best fit between my points. So notice with this point right here, it doesn't go through the point. It finds the line of best fit that goes through all of the points. Okay, so your line may not be perfect, but it's going to be close, or should be close. All right, and then you'll also see this box pop up. This box gives you the equation for your trend line. And again, recall, we're trying to find the slope of this line. The slope of this line is our molar absorptivity value. Okay, so as long as you have this box up on your graph, you're good to go. So I'm going to go up to my File menu, and I'm going to go to Export. I want to make sure that Graph is selected here. And the easiest way to do this is to go down to the lower right-hand corner and to click on the Copy to Clipboard icon. And then I'm going to go back to my lab document and I'm going to paste this in just like that. Okay, so now I have my data table. Of course, you're going to fill in these values, and then I have my graph. Okay, and again, on the graph, our M is our slope. That's our molar absorptivity value. That's what we're going to use to find our concentration. Okay, so we are now done with part 1, and we're going to move into part 2. Part 2 begins with writing out the reaction, so our crystal violet reaction that occurred at part 2. So on my document, I'm going to go down, and I'm going to call this part 2. So the reaction for crystal violet can be found in the background. So if I go to the lab, right at the top here is our reaction for crystal violet. So you're going to go ahead and type that back into your lab document right here. So reaction would go there. The next thing that's required is our table with time, absolute value, or sorry, not absolute value, absorbance, concentration, natural log of the concentration, and then 1 over the concentration. Okay, so what I've done here is I've used the sample data that I posted to Google Classroom. Okay, if you were able to get your values from from the second part of the lab exported, you can use your data, but if not, you're more than welcome to use the sample data that I posted. So we have time and we have absorbance. So the first thing that we're going to need to figure out is our concentration. Now, to find our concentration, we're going to have to do a little bit of math here. Okay, so if you recall from Beer's law states that our absorbance is equal to our molar absorptivity times the path length times the concentration. That's how we relate everything together. Okay, so on our data here, we have absorbance, and we're trying to find the concentration. Okay, that's going to be important for doing the data analysis for the second part. Okay, so we're trying to solve for our concentration, and we have this. Now, if you recall, on our graph, I told you our slope is our molar absorptivity value. So that's the constant that relates our absorbance and concentration. So our slope is going to be, oops, not our C, our slope is going to be this right here. That's our M from the first part. So if I rearrange my equation to solve for C, I'm going to get our absorbance over our molar absorptivity value times the path length. Now, the path length is always 1, so that is the formula right there. So the formula for our concentration will just be the absorbance divided by the molar absorptivity value. Okay, so you're going to need to know what your slope is. If your group already converted the concentrations from micromolar to molar, great. If you didn't, you're going to have to multiply it by 10 to the negative 6. So if you have a micromolar value, if you multiply it by 10 to the negative 6, that will get it to you in molar. So again, if you did not convert your molar absorptivity value and it's in micromolar, please make sure that you convert it. Otherwise, your data is going to look a little wonky. Okay, so I'm going to call this concentration of crystal violet. And let me zoom in just a little bit more so you can actually see what I'm doing. Okay, so on this first heading, I'm going to call it crystal violet. I'm going to go down to cell C2 and I'm going to press equals. That's how Excel knows that this is a formula. And I want to take my absorbance value, so I'm going to click on cell B2. So notice up here it shows equals B2, and I want to divide that by my molar absorptivity. So I'm going to use the value from my graph here, which is 3.383, but you would want to use yours. And it's probably going to give you a really weird number. It's going to be probably really small because, again, remember, we were working in micromolar and we converted it to molar, so it's going to be a very small value. So your number should not look like mine. So that's the formula. Now I need to do that for all of these values. So an easy way to copy that formula and basically have it repeat all the way down, if you look on this green box right here, in the lower right hand corner I have that green square. So if you click and hold and then drag it all the way down, that's going to copy the formula and it's going to repeat it all the way down. But it's not using that first absorbance. So I'll show you what I mean. So it's not using the first absorbance every single time, it's using the next one. So if you notice up here, watch, it goes B2 and then it goes B3, B4, B5. So it's using the absorbance that's directly to the left of it. So it's updating the formula each time. So that's the first thing that we need here. The next one that we need is the natural log of the concentration. So if I go back up here, I'm going to type in ln, and then I'm going to type in CV. This is just a heading here. I want to do the natural log of the concentration. So again, I'm going to write a formula. I'm going to press equals ln, and then I'm going to make a parenthesis, and I'm going to click on the concentration. So this will compute the natural log of that concentration, and I'm going to press enter. Okay, same thing. I want to copy that formula all the way down, so I'm going to grab the box and I'm going to drag it all the way down. So rather than having to do that formula 377 times, it does it all for me. Okay, so I'm going to go back up to the top. All right, the final one that I want to do is going to be 1 over the concentration. So I'm going to go back, I'm going to press equals, I'm going to do 1 divided by, now be careful here, you want to use the concentration, not the natural log of the concentration. So I'm going to, oops, I'm in the wrong box. I want to do 1 over, let's change that heading. Okay, so there we go. So now I want to be in the actual box where I'm doing the data. This is just a heading, don't put an equals here. Okay, so it's going to be equals 1 divided by, and then I'm going to click on the concentration here. And press enter. Same thing, I'm going to drag it all the way down. Great, so now all the math is done for me. Okay, so now the lab document actually tells you to insert your data table with all of this information. That's a lot. That is a lot. Don't do that, okay? I will show you how to save this when we're all done, and you can just include this data file. Okay, now the next thing that it's asking us to do is to insert the graphs. The sample Beer's law calculation to get your concentration, I can show you really quick how to do that. So let me just minimize this. Actually, this is the formula here. So I'm just going to do one calculation here. So sample calculation. So we're going to use the equation editor. So I'm going to go insert equation. So concentration equals absorbance over our molar absorptivity, which is our epsilon. So I'm just going to throw in one of my values. So if I go up here, my absorbance in this value was this number right here. So I'm just going to copy that number. So my concentration is equal to that number divided by my molar absorptivity, which for the purposes of this sample, it was 3.383, but use your value, not mine, and then whatever that turned out to be. So it happened to be, was this value, 0.3072. Okay, and since it's in, since the units here are molarity, I'm just going to put a capital M. Okay, so there's my sample calculation. All right, now let's move on to the graphs. So we need to generate 3 different graphs. We need to do a graph that is concentration versus time, natural log of the concentration versus time, and then 1 over the concentration versus time. So to do this, I'm going to click on the column that has all of the time. I'm going to hold down the control button on my keyboard, and then I'm going to click on the column that has all of the concentrations. I'm going to go up to the top and I'm going to go Insert. I want to go over to Charts, and you want to find the one that says Scatter Plot. It's the one with all the dots on it. So if I click on that, I want to go down to the very first one here. Okay, there's our scatter plot. So I want to cut this, and if you go down to the bottom here, if you click on New Sheet, you can make a new sheet for this graph. So I'm going to call this concentration versus time, and I'm going to paste it in. You can call it whatever you want, but concentration versus time. So there's our first graph. I'm going to repeat the process for my other two. So the second graph that it asks me to make is for our natural log versus time. Okay, so I'm going to go back up. And this time I'm going to click on time. And then I'm going to click on the column that has the natural log of the concentration. Same thing, I'm going to go up to the Insert menu. I'm going to go over to Charts. And I'm going to click on this first one right here. Okay, same thing. I'm going to cut this, and I'm going to make a new tab. This one I'm going to call natural log of the concentration. You can call it whatever you want. Versus concentration versus time. And I'm going to plop that in. Okay, so just to keep everything nice and neat, I'm just doing new tabs for each one. Okay, I'm going to go ahead and do the last one. So it's going to be time and then 1 over the concentration. I'm going to go Insert. Again, scatter plot. I'm going to cut it, and I'm going to put it into a new tab down at the bottom. This is 1 over, I guess you can't do slashes, so 1 over the concentration versus time. You can call them whatever you want. You could call them graph 1, graph 2, graph 3 if you wanted. Okay. Now, this is not a good graph. Like, yeah, the data's there, but of course you want to make sure that you have a heading and you want to have axes labels on here. So I'm going to go up and I'm going to do this for one graph. You would obviously have to do this for all three. So I'm going to click on the plus here, and I want to go to axes titles, and I'm going to rename these. So down at the bottom, this is time, and the units are seconds. Up here, this is the concentration. So I'm just going to put concentration of crystal violet. Up at the top, I'm going to change my title. It's always y-axis versus x-axis. So this is going to be concentration of crystal violet versus time. And you could even, yeah, just leave it like that. That's fine. That's fine. Okay, great. There's my graph. Now, the other thing that you need, because we're basically looking for which graph is a straight line. So we're going to insert a trend line here. So if you go up to the plus sign again, and you go down to trend line, that will plop in a trend line. If you click on the arrow directly to the right of the trend line, you can go to more options. And should be a way to get our, here it is. So if you go over to the graph, down at the very bottom, it says display R² value on chart. If you click on that, that will tell you how close it is to being a straight line. So if your R² value is 1, that's a straight line. If it's not 1, or it's not close to 1, it's not a straight line. So the closer you are to 1, the closer you are to being a straight line. And you can use that R² value, excuse me, to argue which graph is correct. So once you have your graphs, I'm going to go ahead and copy this, and I'm going to paste it into my document. So it asks for all 3 graphs. So you're going to want to make sure that you have all 3 graphs in your lab document here. Where it says choose the correct graph, you would obviously have to identify which of the 3 graphs is correct. And again, if you go back and look at your notes, the straight line, or whichever of the 3 graphs gives us a straight line, is going to determine the reaction order. Once you determine the reaction order, you're going to write the rate law. Make sure to include K with the correct units. So if you recall, oops, let me go back to the actual lab here. So here is our reaction. You need to know what the rate law is based on the graph. So once you know what the rate law is, you can then take the reaction and write the rate law for the reaction. So you'll need to look at the 3 graphs and determine which one's correct. That will tell you the reaction order, and then from there you can go and write the rate law. Okay, so that is how you do the data portion for the lab. Good luck and have fun.